So we have done the non-discounted cash flow techniques, the two. We are moving to the discounted cash flow techniques, begin with the net present value technique. Net present value technique. Net present value technique. Net present value technique. Battery low. Now, the net present value technique is a technique that evaluates the present value of future cash inflows minus the initial investment. So you are getting the difference of two things here. Future cash flows, and that is future cash inflows. You are getting the difference between the net present value of future, the present value of future cash flows, and the present value of inflows. Net present value is calculated by first of all getting the present value of future cash inflows, then we deduct the present value of future outflows. That is to mean that the net present value of a project is equal to the present value of cash inflows minus the present value of cash outflows. You get the difference between the two. And it is that simple, candidates. It doesn't matter how the question is tested. At the end of the day, you just get the difference between these two. You understand? So if a company is evaluating various projects, different projects, the company should accept an investment, a venture, if NPV is positive. Let me call it the acceptance rule. If a company has one project, only one project, then a project should be accepted. When using the NPV value technique, the project with positive NPV is accepted. Accept the project if NPV is greater than 0. But a project is rejected if NPV is less than 0. Where NPV is equal to 0, then the company we say is indifferent. So where NPV is greater than 0, accept the project. Where the project's NPV is less than 0, that project is rejected. Where NPV is equal to 0, the investor is indifferent, meaning the investor can choose to accept or reject the project. So if it's one project, but if there are 2 projects or more, then you compare the project with the highest NPV. You compute the NPV for project A, compute NPV for project B, project C, then check the one that has the highest NPV. That is the project that has to be accepted. That is the acceptance rule. for the NPV technique. Illustration. Tamim Limited. Tamim Limited is considering a capital investment in new equipment valued at 240,000 shillings. The estimated cash flows are as follows: year 1, year 2, year 3, year 4, year 5. We have the cash flows in thousands. These are millions: 80 million, 120 million, 70 million, 40 million, 20 million, respectively. The company's cost of capital is 10%. Calculate the NPV of the project to assess whether it should be undertaken. So the formula, we have it. NPV is equal to present value of cash inflows minus present value of cash outflows. That's the formula. So we have the formula. There are just two variables, inputs. We have the present value of cash inflows minus present value of cash outflows. The cash outflow is the initial investment, which already is in present value. So all we need to do here is to, first of all, get the present value of the cash outflows. So we'll have a solution here. Solution. The years 1, 2, 3, 4, 5. Then we have the cash flows in thousands from the question. 80 million. This should be 80,000. 80 million. 80 million. Just 80 million. 120. Then we have 70. 40. 20. Then we have to discount. Present value means discounting. To get the present value of a cash flow is to discount the cash flow. These cash flows are in future terms. This is money that is expected to be received in future. So we have to discount this money at a discounting rate. Present value interest factor 10%. R, we have the 10, this is 10%, N. So please give me the factors. 10% 1 year, 0 point, 0 point, 0 point, 0 point, 0 point. Give me the factors from the tables. Gilbert has the factors. 1991. 1991, year 2, 8264, year 4, 7513, year 5, 6830, that's year 4, year 5, 6209. Then what are the present values? Multiply the factor by the future cash flows, give me the values, and get the total. Year 1, 72,728, 72,728. Please confirm Gilbert's values. 99,168. 99, 168, year 3, 52, 591, year 4, 27, 320, 27, 320, year 5, 12, 418. What is the total? Total present value, 264, 264, 255. That is the total present value. That is the present value of cash inflow. Okay, this is present value of cash inflow. Then we deduct the present value of cash outflow, the initial investment. Is that so? What is the initial investment? 240. 240. Deduct 240 from that. That should be, is it 24? 280, 255. 284, 255. Positive. This is the NPV. That clear? 225. 225. 225. That is the NPV. So what is the question? Calculate the NPV of the project to assess whether it should be undertaken. So the advice here, the project should be undertaken because it yields a positive NPV. That is the reason why the project should be undertaken. Accept the project. Now, the internal rate of return is another discounted cash flow technique. The internal rate of return. Internal rate of return we can define it as the discount rate that makes NPV of a project equal to 0. It is a discount rate that makes the NPV of a project equal to 0. The internal rate of return is the discount rate that makes the NPV of a project equal to 0. It is a discounted cash flow technique which uses the principle of NPV. It uses the principle of NPV. And it may also be defined as the rate which equates the present value of cash outflows of an investment to the initial investment. Because candidates, where NPV is equal to 0, at this point, the same point where the present value of cash inflows equal the present value of cash outflows. At zero NPV, The present value of cash flows is equal to the present value of cash. Cash inflows equal to present value of cash outflows to the rate which equates the NPV of cash outflows of an investment to the initial capital. That is to say that it is the cost of capital, it is the cost of capital where NPV is equal to 0. It is the cost of capital where NPV is 0. And we are using the NPV principle candidates, that's what we said. And IRR can be done using a programmed calculator, or it has to be estimated using the technique we are calling the interpolation method. In calculating, if you are not using a programmed calculator, then if you are doing it manually, we are going to use the interpolation method. We can estimate the IRR of a project using the interpolation method. The interpolation method. And given that we are using the interpolation method, then the IRR that is produced using this method is just an estimate, and it's not and it may not be arithmetically exact. It may not be arithmetically exact. So what is the formula? Using the interpolation method, what is the formula? Using interpolation method, IRR, the internal rate of return, is equal to LDR. LDR, the lower discounting rate, plus NPV at lower discounting rate over NPV at lower discounting rate, NPV at lower discounting rate minus NPV at higher discounting rate. This is a fraction. We multiply it with the difference between HDR minus LDR, where LDR is a lower discounting rate, HDR is the higher discounting rate, and NPV is a net present value. So this is the decision rule. If you are to use IRR to make investment decision, then if IRR that is calculated is greater than the cost of capital, if IRR is greater than the cost of capital, then the project is acceptable. Accept the project. But if IRR is less than cost of capital of that project, then you reject the project. So that is the formula and the decision rule. Yes, Abraham, we use trial and error, the interpolation method. Illustration. Illustrate. We must illustrate. illustrate. Look at the illustration. A company wants to buy a machine for 13.5 million. The machine is expected to generate cash flow as follows. Year 1, 5 million. Year 2, 8 million. Year 3, 3 million. Required, calculate the project's IRR. Calculate the project's IRR. Now, looking at the formula, candidates, we are required to calculate the NPV of the project at two different costs of capital. The lower discounting rate and the higher discounting rate. We have to calculate NPV of this project at two different costs of capital. We are going to use two different discounting rates, and the NPV should be positive at one cost and negative at the other. You understand, candidates? It is a trial and error method. So we have to use one rate, a rate that will give us a negative NPV, and another one that will give us a positive NPV. So we need to estimate two costs of capital. So what cost of capital should we estimate? Now, one way to estimate, candidates, is by looking at the profits of the project. Look at that project. We are told that the machine, the cash flows, look at the cash flows of the project. We look at the cash flows of the project over its life. So over the 3 years, what are the cash flows? What are the cash flows? We have 5 million plus 8 million plus 3 million. What is the total? That should be, is it 16 million? Then, if you are to deduct the initial cash outlay of the 13.5 million, that expenditure, from the 16 million, what do we have? We are trying to find a way in which we will estimate these two cash outflows. Yeah, Abraham says if you are to take the total cash flows, total cash flows 16 million. 5, it is 5 plus what? 5 plus 8 plus 3. Then if you are to deduct the initial investment, the initial investment is 13. Is it 13? 13.5 million. So the difference, 2.5 million. So Lincoln Mwangi, the formula is internal rate of return is equal to LDR. LDR is the lower discounting rate. Then we have HDR, the higher discounting rate. HDR is the higher discounting rate. LDR is the lower discounting rate. Because in computing IRR, in computing the internal rate of return, we have to discount the cash flows at two discounting rates. All right. So we calculate two net present values for the project at two different costs of capital. This is the net return for 3 years. So on average, the return will be the 2.5 million we divide by 3. How much is it? Averagely. This is for 3 years. If you divide by 3, what is the amount? The average per year. 2.5 million divided by 3. 833. So this is 833. Thousand per year on average. Now, if you are to convert this as a percentage of the initial outlay, what is the return? If you are to convert this as a percentage, we are going to have the 833 we divide by the initial. Initial is how much? 13,500. What is the percentage? So our estimate, we could estimate around this estimate could be around these 6%. It could be 7%. You can do an estimate of 7%, 8%, or 9%. So this calculation is a rough one to help us to avoid many trials candidates. The internal rate of return is likely to be higher than 6%, this 6%. That internal rate of return is most likely to be higher than the 6%, which could be 7%, 8%, or 9%. But let's try the 8%. Let us use 8% to calculate the NPV of this project. We'll have here 1, 2, 3. The cash flows, year 1. Cash flows year 1. 5 million, 8 million, 3 million. 5 million, 8 million, 3 million. So let's discount these cash flows. Present value, these are in thousands. Present value, cash inflow. This is present value of interest factor 8%, N. Use 80%, the 3 years. 8%, 1 year, what are the factors? 920, that is 92.59. The next one is factor 85.73. And lastly, 0.7938. Give me the present values. Present values. Give me the total. Deduct initial cash outlay. $46.29. $46.29. 500. Year 2, 68. Someone says 68.58. 68.58. I'm reading Ambuche's figures, 400. Then you have 23. 81,400. Total cash flows. $13,869. $13,869. $13,869. 300. That is the present value cash inflow. Deduct present value cash outflow of 13. Is it 13,500? What is the NPV? NPV? Are you sure? NPV is 369. Yeah, 369 positive. Positive 369 300. 369 300. That is a positive NPV. Now I might lose some of you here. So we said in computing IRR, we need two discounting rates or two costs of capital. One has to give us a positive NPV. The other one has to give us a negative NPV. And both NPVs must be close to zero. Close to zero. They must give us NPVs close to zero. We calculate two NPVs for the project at two different costs of capital. The two costs of capital should give NPV which is close to zero. So first of all, we found a positive NPV. Then we need to try another cost of capital or discounting rate, which will give us a negative NPV. So the question is, if you are to get a negative NPV here, are we going to use a rate higher than 8% or lower than 8%? Let's try 10%. Let's try 10%. 10%. At 10%, all we need here is the present value interest factors. 10%. Give me the factors. 10% will be 0.9 something. This will be 0.8 something. 0.7 something. 90, 91. 90, 91. 2 years. 82, 64. 82, 64. 3 years. 75, 13. 25, 13. Give me the present values. Multiply that by that. 45, 45, 500. 45, 45, 500. 66, 11, 200. 66, 11, 200. Third year, 22, 53. 22, 53, 900. Give me the total. Deduct the 13, 500. What is the NPV? $13,410. 13,410. 13,410. 600. So what's the NPV? Negative 89, 400. Which is which? Negative 89, 400. Negative 89, 400. Negative 89, 400. That one is closer to 0 than this one. The positive one is many points. Now, this is what we mean. Look at we call it number line. Here we have 0, positives 1, 2, 3, 4, 5, 6. This is 1, negative 1, negative 2, negative 3, negative 4. These points. So the NPVs that we are looking at are NPVs that are close to 0. And you can see this one is 369,300 points away from 0. This one is closer. If you are to go on the negative side, this one is closer to 0. So can we compute this with another discounting rate that will give us a positive NPV close to 0? Which rate should we use here? Which rate do you think we can use? Because that 8% is giving us a very huge figure from 0. But it has to be positive. 9. Abraham says 9. Another one says 7. Let's try 7. 7. Let's try 7. PV IF 7%. This one you may not be able to read it in a table. So, but you can calculate it. This is year 1 will be 1 over 0.07. This is year 1. Year 2 will be 1 over 0. This is 1.07. 1.07 raised to 2. Then here 3, 1 over 1.07 raised to 3. So give me the factors. 1 over 1.07, 9346. Second year, 8934. Third year, 8163. 9346. 8734. It's 8734. Then third year, 8163. So what are the present values? Present values. Year 1, $43.76. $43.76. Year 2, $69.87. $69.87, 200. Year 4, 24. Year 1, 2448. 2448, 900. 43. Year 1, 46, 73. 46, 73. Give me the total. What is the NPV? Deduct 13,500. What is the NPV? Total NPV 0609 609 100. 609 100. Positive. Someone says positive. 609 100. All right. So this was 7. This is 7%. So we are getting a value farther away. It is a worse figure than what we had. So if you are to get a negative, you needed to go. This is it 7? Yeah. So it's good candidates. This is what we mean by trial and error. You understand? This is what we mean by trial and error. Trial and error. So you see this one is an error. We needed a figure that is closer to 0. So if you are to get a figure that is closer than 0, we needed to do more than 8%, not less than 7%. So this is an error. You see the figure is greater than 369. We needed an NPV that is lower than 369,300. If you are to get an NPV that is lower than 369,300, then we cannot use 7%. The more we use a lower rate, the higher we get the NPV. So Ambucho says we needed to use 9% here instead of 7. 9%. So we needed to use 9% N. And I think he has used 9%. Ambucha, when you use 9%, what is the NPV? Ambucha says when you use 9%, the NPV is 139,200. When you use 9%, the NPV is 139. It's 139 or 137? 137,200. 137,200 positive. This 137 is closer to this 0 than the 369. I don't know if you are understanding the concept here, candidates. Trial and error. We need two NPVs computed at two different costs of capital or discounting rates. And the two NPVs that we get must be close to 0. One negative close to 0, another positive close to 0. And to start with the positive, candidates, look at this. The positive, the one that we can use and get to the closest point to 0 has to be 9%. Because when we compute 9%, we get a positive. This is a positive 9. This is positive 137,200. Then the cost of capital that give us a value, a negative value close to 0, it is 10%. Because 10% you are getting 89,400. So the values here, we have a lower discounting rate of 9% and a higher discounting rate of 10%. So you use trial and error method to get the values. Trial and error. Trial and error. That's why I recall candidates, the estimate would either be 7, 8, or 9, using my trick here. It could either be 7, 8, or 9. So when you are doing trials, you don't have to do 10 trials. Okay? So then we can go ahead and plug in these inputs. So we have the lower discounting rate. What is the lower discounting rate? 9%. That is the lower discounting rate. Is it 9? It's 9 and 8. No, it was not 8. 9 and 10. 9 and 10. So the lower discounting rate is 10%. It's 9%. It's 9%. 9% is the lower discounting rate. We add NPV at lower discounting rate. NPV at lower discounting rate. NPV at lower discounting rate. NPV at 9% is 137,200. That is the lower discounting rate. NPV at lower discounting rate, 137,200. This we divide by the NPV at lower discounting rate, which is still 137,200, minus NPV at higher discounting rate. NPV at higher discounting rate of 10%, 89,400. 89,400. So this we will multiply with the difference, 10%, 9%. So that will be the internal rate of return. How much is it? Yeah, two minuses. This is a negative. This is negative, negative. So always candidates here, just you add. Because negative, negative gives you a positive. So the denominator, you add the two values. It is minus, minus, which gives you a positive. So the IRR according to Gilbert is 9.6%. 9.6%. So what is the decision rule for IRR? Now for IRR, we compare the IRR with the cost of capital. If IRR is greater than cost of capital, so cost of capital is the hurdle rate. This one you accept. But if IRR is less than the cost of capital, reject. So for this project, what is the decision? We have the cost of the project. You have the cost of the project from the question. Bye-bye.